In today's video, I'm going to teach you everything you need to know about network in graph theory, and we'll start right now. Hello everyone, my name is Shirley and welcome back to my channel. If this is your first time here and you'd like to improve in your math skills, start now by subscribing and clicking the bell so that you don't miss anything. Let's take a look at the first part of the chapter. The first part that we're going to learn for this chapter is to understand the relationship between a graph and a network. So what is a graph? So graph is used to represent data of discrete objects and to show the relationship between these objects in a simple graphical manner. So what is the meaning of discrete? Okay, discrete means finite or countable number of possible outcomes which can be listed. For example, the number of burger restaurants in a city, or the number of possible outcomes when rolling a die. So graph is interpreted as a series of dots which are either linked or not linked to one another by lines. So vertex means dot and edge means line joining two vertices. Okay, so in this chapter we get to see a lot of V's and E's, okay, that comes out in the examples and also the questions. So network, what is a network? So network is part of a graph with many vertices and edges, having their own characteristics. So a graph is denoted by a set of ordered pairs, okay, which is G, V, E. Okay, V stands for vertex and E stands for edge. Okay, so V, big V stands for a set of dots or vertices, or we can write it in the set form, which is V1, V2, V3 and so on until Vn. So these are the elements of V. Okay, what is E? E is a set of edges or lines linking each pair of vertices. So normally write in the set form, okay, E1, E2, E3 and so on. So E is the elements of E, okay, set E. So we can also write in pairs of vertices, okay, which is A1, B1 in bracket, A2, B2 in bracket, and so on, okay. All of them we write in braces, which is in set form. Okay, so what is degree? So D, we represent D, okay, represented by D, okay. It stands for a number of edges that connect two vertices, okay. And next will be sum of degrees. So sum of degrees is twice the number of edges. Okay, so the formula is sigma dV equals to 2E. So remember to memorize this formula. Okay, later we're going to use this in the examples. What's the meaning of simple graph? A simple graph means no loops and no multiple edges. Okay, remember this formula? Okay, the sum of dV equals to 2E means the sum of degrees of a graph is twice the number of edges. Okay, let's look at this example. For the graph below, determine V and NV, which means V stands for vertex. Okay, NV stands for the number of vertices. And then number 2, E and NE. So E stands for edge and NE stands for the number of edges. Then number 3 is the sum of degrees. So we're going to apply this formula into here. Okay, so let's look at this diagram. So in this diagram, we have A, B, C, D, E, F. So these are the vertices. Okay, so let's work out for number 1. So V will be the vertices, okay, which are A, B, C, D, E, and F. Okay, therefore, the number of vertices will be equals to 1, 2, 3, 4, 5, 6. So 6. Okay. And next, number 2, edges, so edge. Okay, so edges will be the line which joins two vertices, say from A to B. Okay, so I'm going to write in set form. So in ordered pairs, A, B. Okay, A, B means that the line that joins from A to B. Okay, next will be B, C, means B joined to C. So here, B joined to C. Okay, so BC. And then CD here. So CD. Okay, next will be D joined to E. So D joined to E. Okay, and then E joined to F. E joined to F. And the next will be A joined to F. So it'll be AF. And then next will be B joined to E. So BE. And then next will be C joined to E. So we have CE. Okay, so therefore the number of edges will be, let's count, 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 8. Okay, so next will be finding the sum of degrees. Okay, so sum of degrees. So the formula is sigma dV equals to 2E. Okay, it means that it's twice the number of edges. So number of edges that we found in question 2 is 8. So we multiply by 8. So 2 times 8 is 16. So that's the answer. Okay, the next part is to understand the meaning of multiple edges and loops of a graph. Okay, so multiple edges, it involves two vertices. Okay, I take this as an example. You see the gold string. Okay, the gold string represents the vertices. Okay, so the vertices are connected by more than one edge. Say here. So here to here is one edge, and then over here to here is another edge. Okay, so the sum of degrees is twice the number of edge. As for loops, okay, so I remove one gold string so that I will make up one vertex. So now we have only one vertex over here. You see the gold string here? Okay, so if we have one vertex here, so it involves only one vertex, so it's a loop. Okay, a loop can be a circle shape or oval shape. Okay, so the edge is in the form of an arc that starts and ends at the same vertex. It means that here, this is the gold string is over here. Okay, so it starts and ends, and then another round it starts and ends. So each loop adds 2 to the degree. Okay, so let's look at this example. So for the graph below, determine V and NV, E and NE, and the sum of degrees. Okay, let's work this out. So for question number 1, okay, so V will be the vertex. So how many vertices are there? So we have P, Q, R, S, T, U, and O. Okay, so I'm going to write O first. Okay, if possible, write in alphabetical order. So we have O, P, Q, R, S, T, and U. Okay, so the number of vertices is equals to 1, 2, 3, 4, 5, 6, 7. So 7. Okay, let's look at number 2. Okay, find the edges. Okay, so let's count together. So we have PU and PU. Okay, so I'm going to write here PU, PU. Okay, so next will be here UT and UT. So UT and UT. Okay, and then next will be QR and QR. So we have QR and QR. And then next we have RS to RS. So RS to RS. Okay, so next we have R to R. Okay, so we have R to R. Okay, next we have P, Q. So we have PQ. Then we have S, T. So we have ST. And then we have P, O. Okay, so we have PO. And then we have QO. And we have OT. And we have OS. Okay. Then we have UO. And then we have OR. Okay, so therefore the number of edges will be, okay, let's count together. We have 1, 2, 3, okay, so I have to put in bracket, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So therefore the answer is 17. Okay? Okay, let's answer question number 3, sum of degrees. Okay, so the sum of degrees, the formula is dv equals to 2e. Okay, so the number of edges that we got just now was 17. So I'm going to put this 17 over to here. Okay, so 2 times 17, and the answer is 34. So that's the answer. What are the differences between directed graphs and undirected graphs? So directed graphs means with direction. You can see arrows in the diagram. Whereas undirected graphs means no direction. Okay, there'll be no arrows in the diagram. So let's look at these simple graphs. So for undirected graph, we have 4 vertices, A, B, C, and D. So therefore the V's are A, B, C, and D. So these are the vertices. Okay, E stands for edge. So the edges are, so we have AB, so AB, and we have BC, so BC, we have AC, here to here, AC, AC, okay, and we have DC, so DC, okay, DC or CD, it doesn't matter for undirected graphs. Okay, for DA, so it means that how many edges that is coming in or out from vertex A. So you have 1 and 2. So we have 2 here. DB is 1, 2, 2 also. DC is 1, 2, 3. So we have 3. And from D, okay, DD is 1. Okay, so the sum of DV will be 4, 5, 6, 7, 8. So 8. Okay? So for directed graph, you see the arrows in the diagram. It means that there's direction. Okay, so we have to be extra careful in this type of question. So for vertex V, so V, we have A, B, C, and D. So it's the same as undirected graph. Okay, then the edges you have to be careful because there's direction. So we have BA, so BA in bracket, and then we have BC, so we have BC in bracket, and then we have CA, okay, we have CA, and then we have DC, DC, okay. So let's look at the next part, which is D in A, D out A. So what's the meaning of this? So D in stands for the number of edges that is going into vertex A, okay, and D out means that the number of edges that is coming out from A. Okay, let's solve this. So D in A, so we have 1 and we have 2, okay, so we have 2 here. D out A, that's nothing, so it's 0. Then D in B, also 0. D out B, we have 1 and 2. So we have 2 here. Okay, D in C, we have 1 and 2. D out C, we have 1 here. So 1. D in D, 0. D out D, we have 1. Okay, which is 1. Okay, so the sum of everything, so 2, 4, 6, 8. The answer is 8. Let's look at the next part. For graphs with loops and multiple edges, okay, we have undirected graph and directed graph. So undirected graph means without direction given, and directed graph means with direction given. Okay, so to find V, V are the vertices. We have P, Q, R, S, and T. So I'm going to write it here, P, Q, R, S, and T. Okay? So next, to find the E are the edges. So we have PQ, QR, RQ. Okay, I'm going to write here first. So PQ, then QR, RQ, and then we have QS, so QS, then we have TS, so TS, then we have TT, which is a loop, TT, then we have PT. Okay, so next, we're going to find the DP, means the number of edges coming in or out from vertex P. So we have 1, 2, so we have 2. DQ will be 1, 2, 3, 4, so we have 4. DR will be 1, 2, so 2. DS will be 1, 2, so 2. DT will be 1, 2, 3, and 4, so 4. So total everything is 14. Okay? Now let's look at directed graph. Okay, V are the vertices, P, Q, R, S, and T. P, Q, R, S, and T. And this is the same as just now, the undirected graph. Okay? So let's look at the edges. So for this part, you have to be very careful because there's direction. So you have to look at the direction. So the first one is P to Q. So I'm going to write here PQ, PQ. Okay? Next will be Q to R. So we have Q to R. And then we have R to Q. So R to Q. Then we have S to Q. So S to Q. Then we have T to S. So T to S. Then we have TT, which is a loop. So TT. And then we have T to P. T to P. Okay? Now let's solve the next question, which is finding D in P and D out P. So D in P means the number of edges that is going into vertex P. So we have here 1, so 1. Okay? Then D out P means the number of edges coming out from vertex P. So we have 1 here. So 1. Okay? So D in Q, 1, 2, and 3. So we have 3 here. D out Q, coming out from Q. So here we have 1. Okay, D in R, going into R, we have 1. D out R, coming out from R, we have another 1. And then D in S, going into S, we have 1. Okay, D out S, coming out from S, we have 1. Then D in T, going into T, we have 1 here, which is a loop. Then D out T, we have 1 here, another 1 here, and then the loop is considered as another 1. So total is 3. Okay, so the sum of DV, for this, we add up everything, 1 plus 3 plus 1 plus 1 plus 1 plus 1, 1, 1, 1, 3. Okay, all these plus together, so total is 14. That's the answer. What are the differences between weighted graphs and unweighted graphs? So the main difference is the value on its edges. So for weighted graph, there will be a value on its edges. Whereas unweighted graph, there's no value on its edges. Okay, let's look at the example in the table. So for weighted graph, the examples are distance between two places, okay, in kilometer or meter, then traveling time in hour and minutes, current in an electrical circuit in ampere, and cost in RM. Okay, so all this is under weighted graph. Okay, for unweighted graph, okay, they're not associated with a value or a weight, so there's no value on its edges. So for example, flow map, tree map, bubble map, and job hierarchy. Okay, let's look at this example. The diagram below shows one-way path that Ezra can choose for his running practice. Vertex B1 is the starting position, so here's the starting position, and vertex B5 is the ending position. Okay, that's the ending position before he goes home. So A, find the shortest distance from V1 to V5. Okay, so I'm going to use V1 to V2 and then V2 to V5. Okay, so V1 to V2 and then to V5. Okay, So let's calculate this. 600 meters plus 500 meters. So 600 meters plus with 500 meters. So we'll get 1,100 meters. And then we convert to kilometers, become 1.1 kilometers. Okay, next B, find the longest distance, V1 to V5. So you have to try a few routes and see which is the longest distance, okay? Okay, I'm going to use blue. So I'm going to use starting from V1, okay? I will go to V2, okay, represented by the blue arrow. And then I will go to V3 here. Then I will go to V4 and go to V5, okay? So V1 to V2, then go to V3, then go to V4, and then go to V5. Okay, so it will be 600 meters plus 900 meters plus 500 meters and plus 500 meters. So total is 2,500 meters. And then we convert to kilometer, it becomes 2.5 km. Okay? So let's look at C. Okay, the vertices that must be passed through if the distance of the one-way run is between 1.4 kilometers and 2.1 kilometers. Okay, let's find what are the vertices. So we can use V1 to V3 here, okay, and then to V4 and to V5. Okay, so these are the vertices that I can add up, okay, and it's between 1.4 kilometer and 2.1 kilometers. So V1, V3, then V4 and V5. Okay, so when I add up, this is 500, 500, 500, 500, 500, okay, plus 500 meters, plus 500 meters, which is 1,500 meters, and is 1.5 kilometers. Okay, so this is between 1.4 and 2.1. Okay, so this is the answer. Okay, and V1, V3, V4, V5 are the vertices. Okay, we can try another one. Say I use red. Okay, use red. So I can try V1. Okay, go to V2 here, V2, okay, represented by the red arrow. Then V2 can go to V4 here, and then V4 go to V5. Okay, so it will be V1, V2, V4, and V5. Okay, let's prove it. So V1 to V2 is 600 meters, then plus, then V2 is V2, okay, to V4 is 800 meters, and V4 to V5 is 500 meters. Okay, let's plus this together. We'll get 1,900 meters. So we convert to kilometer, become 1.9 kilometers. So this is also between 1.4 and 2.1 kilometers. So therefore, the vertices that must be passed through is V1, V2, V4, and V5. Okay, so that is the answer. What is a subgraph? A subgraph is part of a graph or the whole graph is drawn without changing its original positions of the edges and vertices. So a graph H is said to be a subgraph of G if A, VH is a subset of VG, B, EH is a subset of EG, okay, and C, vertex pairs of the edges of graph H are the same as the edges of graph G. Let's look at these examples. Okay, determine whether diagram 1, 2, 3, and 4 are the subgraphs of graph G. So here, we're going to use this as a reference, graph G. Okay, let's look at 1. Is 1 a subgraph of graph G? So PS, okay, so P and S is correct, this is correct, this is correct, and E5 is also correct. So therefore, 1 is a subgraph of graph G. Let's look at number 2. Let's compare. So P is correct, S correct, E5 correct, Q correct, but the loop is not correct. Okay, the loop is supposed to be here, right? Okay, so this is not a subgraph of graph G. Let's look at 3. So we have P to S, correct, but the age is not correct. This is not correct. It's supposed to be E5. Okay? And then this line is not drawn, so it's not correct. Okay? So E2 is correct. So therefore, this is not a subgraph of graph G. Let's look at number 4. So we have PQRS. Okay, so the 4 vertices are correct. Okay, let's look at the ages. E5, correct. And then we have E4. And then E1 is correct. Okay, but this is not correct. It's supposed to be E3. And then E3 is supposed to be E2. So therefore, this is not a subgraph of graph G. What is a tree? So a tree is a subgraph of the graph with the following properties. So a simple graph without loops and multiple edges. All the vertices are connected and each pair of the vertices is connected by only one edge. So the formula NE equals to NV minus 1. So with all these properties, therefore it's a tree. Okay, let's look at the following example. Determine whether each of the following graph is a tree. Justify your answer. Okay, means you must give proof. Okay, why you say yes or no. So let's look at A. Is this a tree? Okay, so we find what is the N, V, and NE. Okay, so the NV, how many vertices are there? So we have P, Q, R, S, T, and U. Okay, so we have 6. Okay, and then the NE, how many edges? We have 1, 2, 3, 4, 5, and 6. And 7. Okay, so we have 7 here. So NE is supposed to be NV minus 1, so it doesn't satisfy the formula. Okay, and each pair of the vertices can be connected in various ways in this question. So therefore, it's not a tree. No. Okay, let's look at B. So NV is equals to 6. Okay, because PQR, STU, there are 6 vertices. And NE, okay, let's see how many edges. So 1, 2, 3, 4, and 5. Okay, so this satisfies the formula. Okay, and each pair of the vertices is connected by only one edge. So therefore, it's a yes. Okay, let's look at C. Yeah? So the number of vertices and the number of edges. Okay, so the number of vertices, so we have 1, 2, 3, 4, 5, 6. So we have 6 vertices. Okay, number of edges will be 1, 2, 3, 4, and 5. Okay, it satisfies. Okay, satisfy the requirement, the properties of a tree. Okay, so double check again. So is it each pair of the vertices are connected with only one edge? So yes. So therefore, this is also a tree. Okay, let's look at D. So NV and NE. Okay, so we have PQR, STU. So we have 6. Number of edges will be 1, 2, 3, and 4. So this one doesn't satisfy the formula of NE equals to NV minus 1. Okay, and then you see here, the R and the T, this R and this T, okay, they are not connected to other vertices. So therefore, it is not a tree. So it's a no. Okay? Well, that's all for now. Stay tuned to my next video, which is solving problems involving network in graph theory, coming up soon. Bye!